Okay, so yesterday we talked about initial sides of angles and terminal sides of angles. Where does your angle begin? Where does your angle end? We talked about the difference in positive and negative angles. And you've got your unit circle, yummy angles that we are going to know a lot about, your special angles. Your green sheet, that's what your test is going to be. Your quiz is going to look like on Monday. You're going to get a blank one. You need to know them. Fill them in, both your radians and your degrees with on that, with on. Thank you, ma'am. I hit pause, right? Oh, I didn't hit pause. I was supposed to hit pause. I didn't. It's all good. Okay, so today, the first thing that we're going to talk about is we're going to talk about coterminal angles. Okay, and coterminal angles, it's the family of angles that have the same initial side and the same terminal side the whole way through. So if you think about drawing the angle that starts on the green line and ends on the red line, okay, we're going to label this as 225 degrees because that's what I drew it to be. Okay, and that would be considered a positive angle. Now, I can also draw an angle that goes the other direction that has the same initial side and the same terminal side. I can start on the green and I can go backwards until I hit the red, and this would be labeled as negative 135 degrees. Okay, those would be considered coterminal angles. They have the same initial side, they have the same terminal side. Now, there's a whole family of them out there where this works. If you think about the angle where there's more revolutions that happen, I can start on the green and stop on the red, and then I can go around the circle again. And isn't that black angle still have the same initial side and the same terminal side as the other two angles that we had? So if you think about, we just added a revolution. I started at 225 degrees. I added a full circle, which would be 360 degrees. So my coterminal angle for this one would be 585 degrees, would also be a coterminal angle. If I wanted to go around the circle again, what would I have to add to 585 degrees to make it work? I'd still have to add another 360. So I could also add another 360 degrees, and I would get 945 degrees. This angle, along with 585, along with 225, along with negative 135, those are all coterminal angles. Now, I can add a positive 360. Can I also add a negative 360 and go around the circle again the negative way? Okay. So as I go around the circle again the negative way, I would go all the way around again. I started at negative 135, and I went backwards another 360 degrees. So it would be at negative 495 degrees. So all of those circled angles we would talk about being coterminal. They begin and they end on the same sides. Their measures are just different. Okay. Now, it's easy to see when it comes to the degrees what happens when we write things in radians. Okay, our eyes see things a little bit differently. So if I look at the angle over here, this angle that we're given, this is pi over 3. Okay. Once again, the initial side is the green. We're on the positive x-axis is where we start, and where we're ending, we're telling it where we're ending on that red line. Okay. If I want to do the most obvious negative one within here, I can also start and go backwards, and there's my negative angle that's there. What do I have left from 2 pi? What would be the measure of the red angle? If I start in radians, I want my answer in radians. So instead of it being 300 degrees, what would my answer be in terms of radians? Negative 5 pi over 3. Good. Okay, and that's a very good thing for you to do. If it starts in radians, you want your answer in radians. If you're thinking degrees and you can do that shift in your head, put the answer of radians on your paper. Okay. All right. Now, in a similar fashion, we can find more of them that are coterminal. We would just go around the circle again. So this time around, I would have my pi over 3 is where we started. We went around the circle again, which is 2 pi. Okay, get your common denominator. 2 pi written with a denominator of 3 is really 6 pi over 3. And I'm going to add my pi over 3. That gets me to 7 pi over 3. Okay, so that's another coterminal angle. If I wanted to add another 2 pi to that to get another one, I can do that. I can continually add 2 pi to things. Okay. In a similar manner, I can do the same thing with my negative, and I can continually go, I can go all the way around again, which would mean I would be at negative 5 pi over 3, and then I would go backwards another 2 pi. So if you think about writing that negative 2 pi with a common denominator, we're looking at a negative 6 pi over 3. I have negative 5 pi over 3. So my angle is 11 pi over 3, and it's negative. So all of those angles, once again, are all the circled angles. These are all angles that are coterminal. They begin and end in the same place, but the measure around them is different. Okay. So the note for you as you're looking at coterminal angles is make sure that to find your coterminal angles, we're going to add or subtract 360 degrees or your 2 pi from each of those angles. And you can do it more than once. If it asks you to find 2 positives, add 2 pi a couple times. If it says to find 2 negatives, subtract 2 pi a couple times. Okay? Now this morning they didn't want to see more examples. They felt that they understood it from the 2 that was given. Do I need to go through another example at all here? Are we okay with the understanding of what we're doing? Okay. All right. All right, so now the next part, we've already talked about the difference in degrees and radians. There's different ways to write degrees. There's degrees as decimals, and there's degrees as degrees, minutes, and seconds. Okay, and so if you look at the two things that we've got here, this 50 degrees, 50.3417 degrees, is the same as writing 50 degrees, 20 minutes, and 30 seconds. It's a different way to write things. It'd be kind of like sometimes writing 39.77 million instead of 39,770,000. There's just different ways to write the same thing. Okay. When we're dealing with where small parts matters, okay, if you're in navigation, a small error on a boat or on a ship in the ocean can get you in a really far off the course place, even though it's a small part. So when you're dealing with navigation, they deal with the degrees, minutes, and seconds because the tiny parts of the angle matter. Okay. So let's look at what this means and how we might do this. Okay, we're going to look for conversions. You're very comfortable with conversions. Okay, you know how to convert from yards and feet and inches and all that sort of thing. This is no different. Think of your degrees, minutes, and seconds. Think of a clock. Okay, if I have 15 minutes, 15 minutes is a quarter of an hour. I can write that as a decimal of 0.25 hours. So if I have 52 degrees and 15 minutes, my decimal that matches would be 52.25 degrees. So don't make the degrees, minutes, and seconds harder than needs to. Think of your clock. Okay? And so your conversions are what follows below. 1 degree is equal to 60 minutes. Just like pi was equal to 180 degrees. This is 1 degree is 60 minutes. 1 minute, you already know, is 60 seconds. So if we use the two of those, if I convert 1 degree in terms of seconds, 60 times 60 gets us to 3,600 seconds are in 1 degree. You're kind of understanding where these conversions are coming from. That's what we're going to use to make our conversions on the next page. Okay, so once again, we have our Greek letters that we're going to refer to. Your book in your assignment is going to say, hey, theta is a certain degree. Make sure you make the conversion. That's all it's telling you. Maybe it's going to say, hey, alpha is a certain degree. Make the conversion that's being asked. Okay. So I'm looking at my 115 degrees, 26 minutes, and 27 seconds, and it wants me to convert it to decimal form. It just wants the decimal answer. Okay. So you're going to take your degree is going to stay the same. This is going to be what's out front of your decimal place and cross it off. That degree is still going to be there. Our job now is to convert the minutes to degrees and to convert the seconds to degrees. Okay, so as we look at the minutes that we have 26 minutes. So if you think about 26 minutes and you think about your conversions, we know that in 1 degree there is 60 minutes. So think about, we want the minutes to cancel. I have 60 minutes on the bottom. I have 1 degree on the top. Get your calculators out, divide that out so we get our decimal. If you don't have a calculator, get one so you can participate with stuff today. And it continues, right? It's at 0.433, okay? So 0.4333 repeating, okay? All right, that's going to be part of our decimal. Now the other part we want to convert our seconds. We want to convert our seconds to degrees as well. So if you think about having 27 seconds, okay, how many seconds were there in a minute? Or sorry, how many seconds were there in a degree? That was that, yep, okay, so we've got 3,600 seconds are in 1 degree. That was our conversion from before. Otherwise, you can convert to minutes and then convert your minutes to seconds, 60 times 60 on the bottom. When you divide things out, Macy, what'd you have? 0.0075, okay. What do you think I need to do with the 2 decimal portions? Add them together. So if we add these together, then that's going to be our decimal portion of our angle in decimal form. I think it's 0.4408-ish, around there, okay? All right, and when it's going to be in decimal form, they want you to go out pretty far. It's usually 3 or 4 decimal places that they're going to want you to go out to. So don't round too soon. Don't round that to just a singleton there, okay? There are questions for clarification so far? Yes. If I'm a ship captain, completely and totally, I need to make sure that with my angles, if I'm approximating with a decimal, they're going to change. They've got all their instruments that they're changing to things in degrees and minutes and seconds instead of that decimal, because it gets more accuracy. There's less rounding that's involved with that. If you're looking at the instrument panel within what a pilot's doing, it's going to be there as well. So what we're using it for, we're getting you ready for what you might use it for. Engineers will use it when tiny portions of the angle matter. Okay, so now let's do the second conversion. Okay, we're given that alpha is 4. What does this 4 represent? Is it degrees or is it radians? If there's no units, what is it? It's radians. So my first job, if I want to convert this to degrees, minutes, and seconds, is I need to convert the 4. I've got to convert to degrees first because it's in radians right now. So I got my 4, and I need to multiply by my pi over, just kidding, I need to convert to my 4 is on top. I need my radians to cancel, so my degrees is on top. Okay, so get your calculators out. Get that angle figured out. What is 4 radians equal to? Say it again. Divide by pi. I like that much better. 229.1831181 degrees. Okay. Don't forget to divide by pi. The radian unit canceled out, but the number was still there, so get that divided by. Now what we're doing is we are converting this to degrees, minutes, and seconds. Once again, your degree is going to stay the same. I'm going to keep my 229 degrees. My job now is to convert the rest of that decimal into minutes and then convert to seconds from there. Okay. So we're going to take that 0.1831181, that's degrees, and I want to convert now to minutes. I'm going to work down. I started at degrees, then I'll convert to my minutes. So I have 1 degree is how many minutes? Is 60 minutes. So now do your math. You'll multiply across the top. And don't round this, write exactly what it is, what you get. Okay. And the units on that, make sure you put 1 hash mark. The units on that is your minutes. Okay. Now what we're going to take from this to put into our final answer is we're going to just take that 10. That 10 is going to go up here, and we're going to say it's 10 minutes. What we want to do next then is take the decimal that's left, and now we're going to convert from that minutes into seconds. So now I've got 0.987086. I've got those minutes, and I know that 1 minute has 60 seconds. I want to convert the minutes now to seconds. So I'm taking that last portion and now multiplying that by 60. 59.22516, and the units on that was the double hashtag or the double apostrophe. The only part we're going to take with us is the 59. Nope. It's there somewhere. Okay, I'm going to take the 59, and we're going to write 59 minutes or seconds behind it.
If it's like the number behind 59 is like 59.5, you round up.
Then you could round up. Yep, if that was a 0.5, you could round up. Okay? This is something that there's a couple more examples in your book. If there's questions that you're having, make sure you refer back to the notes, the book, Google it, look for some YouTube stuff to help you with that. Okay? But for one more example, why don't you try number 1? Okay? Convert that to degrees, minutes, and seconds. Okay. All right. The second part of today then is a couple new formulas. I would flip my green sheet over that you have of your unit circle. I would write these rather small. I would not write them very big. You have a lot of information you're going to be putting on here as we go through. Okay. Your arc length is going to be representative of your letter S. When you see S from here on out, you're going to understand that S is going to be what our arc length is. S equals R times theta, R being our radius, and theta has to be in radians. For both of these formulas, if your angle is not in radians, you cannot use this formula. This formula only works if your angle measure is in radians. So we're going to get good at using our formulas. Okay, area of a sector is going to be your piece of your pie. Half area is half r squared times your theta. Once again, your angle must be in radians. Okay, so the next 2 examples utilize these formulas. Okay, and they ask things for you kind of in an abstract way sometimes. It talks about, this particular one talks about if a circular arc of a given length s subtends the central angle theta on the circle, find the radius of the circle. Okay, so when you think about circular arc, we're talking arc length, we're talking about subtends. Subtends means to be on the outside. It's opposite the central angle. Central angle is an angle that's made with the origin or made with the center of the circle. Okay, so we're given that our arc length is 10. We know that our angle itself is 229.18 degrees. So let's draw that. Let's get that on our circle. I've got my center. I'm always starting on that positive x-axis part of our circle. And as I go around, 229 is somewhere in quadrant 3 if you're thinking about quadrants. So as long as you draw something in there and you label it, you're good to go. Doesn't have to be completely accurate. Get it in the right quadrant so it gives you a good enough picture of what you're talking about. Okay, the arc length is what would be on the circle on the outside. So our arc length on the outside, that is considered to be 10 centimeters. Okay, what we're looking for is we're looking for the radius. So I know that my arc length formula is S equals R times theta. What has to be true of theta is that theta has to be in radians. Is the angle that we have given to us in radians? No. So we have to convert the radians first. So I get things out. I'm going to divide by 180 degrees, and I'm going to multiply by pi in order to have the accurate type of angle that we need. Josh, do you have it? Yep, 3.99. Okay, and some of us might want to really round that to 4. Don't. Keep it out a couple until you can't round anymore with that, because 4 will change your answer. So I've got 3.99 radians. That's what's going to be plugged in here. So my arc length is 10 equals r times 3.99, dividing by 3.99 to get what my radius measure is. .5 centimeters is an equivalency. Okay, it's about 2.5 centimeters as we go through. Once again, make sure that your angle is in radians for this. These formulas aren't too difficult to use. The issue that we're going to have with them, that we need to be good at them right now, is so that when we, after our quiz on Monday, we'll talk about linear speed and our angular speed. How far did that particular object go that was stuck in your tire? What was its speed linearly? What was its angular speed? How fast was it going? We'll be utilizing this then, okay? Find the length of the arc on the circle with radius 9 and a central angle of 120 degrees. Then find the area of the sector. So we got a couple different things that are going on here. We know that our radius is 9. So let's draw our radius in there, and our radius is 9 centimeters. The central angle is 120. We know we're in quadrant 2. Okay, so I'm going to draw my angle in here. I'm going to label this. This is 120 degrees. What we're trying to find this time around is we're trying to find the outskirts here. What is our S? Okay, so we know that our arc length is going to be our radius times our angle. Our angle has to be in radians. Are we there? No. So this is a nice angle. This is a yummy angle, 120 degrees. What is our radian measure? Good. So this is really a 2 pi over 3. So as we plug things into our formula, I've got 9 times 2 pi over 3. And I have 18 pi divided by 3 is going to get me to 6 pi. When you multiply things through, our arc length is about, say it again. Did you divide by 3? I don't know. I don't know how you got 169. 6 pi is going to be just bigger than 18, I think. Okay, what'd you do? Got it. 18.84 centimeters is our arc length. Okay. Using our other formula, we're going to have our area. The area of our sector is 1/2 r squared theta. So we get 1/2 r squared is going to be 81 times theta, and theta is 2 pi over 3. Once again, make sure that you have things in terms of your radians. If you put in 120 degrees, your answer is way off. So get that switched over, okay? My 2's cancel out. My 3 goes into my 81, and my exact answer would be 27 pi. But if we wanted to multiply things through, 27 times pi gets us to 84.82. Anybody else agree with that? And our units on that, we're talking centimeters squared because we're talking area. Okay. Take some time and play with the degrees, minutes, and seconds. Make sure you can get those conversions. That's usually the most difficult part of today's lesson with that. Okay. Questions that you're having? Mm-hmm. Oh, area of a circle of the whole thing. Area of a circle is pi r squared. Okay. All right. There we go.